There are several potential causes for sparking from a dryer receptacle. Firstly, loose connections. Check if the receptacle screws are properly tightened, ensuring a secure connection between the plug and the receptacle. Inspect the cord and plug terminals and ensure they are properly crimped or screwed on. Secondly, incorrect cord or plug. Verify that the cord and plug are rated for 30 amps and matches the receptacle type. Inspect the cord for any damage or loose connections. Thirdly, a faulty cord and plug. Replace the cord and plug with a new one from a reputable manufacturer. Ensure the new cord and plug is compatible with the receptacle and dryer. Fourthly, a damaged receptacle. Check if the receptacle is damaged or has loose terminals. If necessary, replace the receptacle with a new one. Fifthly, insufficient sleeving. Ensure that the non-metallic cable is properly sleeved with electrical metallic tubing all the way from the panel to the receptacle. Loose or damaged sleeving can expose the conductors to moisture or damage. Additional troubleshooting steps include inspecting the breaker. Verify that the quad-ohm breaker is properly tightened and securely seated in the panel. Test the receptacle. Use a non-contact voltage tester to ensure the receptacle is receiving power. Isolate the problem by turning off the breaker and unplugging the dryer. Then test the receptacle and cord and plug separately to identify the faulty component. Consult the manufacturer. Contact the manufacturers of the receptacle, cord and plug, and dryer for technical assistance. Safety precautions are crucial. Before performing any troubleshooting or repairs, disconnect the power supply to the circuit. Use gloves and safety glasses when working with electrical equipment. If the problem persists or you are unsure about the cause, contact a licensed electrician for further assistance. A more detailed look into each of these potential causes begins with loose connections. Electrical connections, particularly those handling high amperage loads like a dryer, are prone to loosening over time due to thermal expansion and contraction from heating and cooling cycles. This loosening increases resistance at the connection point, leading to heat generation and potentially sparking. Begin by turning off the breaker that supplies power to the dryer circuit. This is the most critical safety step to prevent electrical shock. Using a screwdriver, carefully tighten the screws that secure the wires to the receptacle terminals. Ensure that the wires are making solid contact with the metal terminals. Do not over-tighten, as this can strip the screw threads or damage the receptacle. Similarly, inspect the terminals on the cord and plug, ensuring that the wires are securely attached. If the wires are crimped, verify that the crimps are tight and free of corrosion. If the wires are screwed in, tighten the screws as you did with the receptacle. If any wires appear frayed or damaged, trim them back to expose fresh wire before reconnecting. If the insulation on the wires is damaged, consider replacing the entire cord and plug assembly. The second possible cause, an incorrect cord or plug, involves mismatches in amperage ratings and plug configurations. Dryer circuits are typically either 30 amps or 50 amps, and the cord and plug must be rated for at least the amperage of the circuit. A cord or plug with a lower amperage rating can overheat and cause sparking. In North America, dryer receptacles are typically either 3-prong or 4-prong. The cord and plug must match the receptacle configuration to ensure proper grounding and prevent electrical hazards. Check the amperage rating printed on the cord and plug. It should match the amperage rating of the breaker protecting the dryer circuit. If the amperage rating is too low, replace the cord and plug with one that is properly rated. Compare the configuration of the plug to the receptacle. If they do not match, do not attempt to force the plug into the receptacle. Replace either the receptacle or the cord and plug to ensure compatibility. Inspect the cord for any signs of damage, such as cuts, abrasions, or kinks. If the cord is damaged, replace it immediately. A damaged cord can create a short circuit or ground fault, leading to sparking and potentially a fire. The third possibility includes a faulty cord and plug. Even if the cord and plug are correctly rated and properly installed, they can still fail due to manufacturing defects, wear and tear, or exposure to moisture. Internal corrosion or broken wires within the cord can create high resistance connections, leading to heat and sparking. Purchase a new cord and plug from a reputable manufacturer. Avoid generic or low-cost options, as they may not meet the same quality standards. Ensure that the new cord and plug are specifically designed for dryer applications and are compatible with your receptacle type. Carefully follow the manufacturer's instructions for installing the new cord and plug. Pay close attention to the wiring diagram to ensure that the wires are connected to the correct terminals. After installation, inspect the cord and plug for any signs of damage or loose connections. A fourth potential cause is a damaged receptacle. The receptacle itself can become damaged over time due to repeated use, overheating, or physical impact. Cracks, burns, or loose terminals can create high-resistance connections and lead to sparking. Carefully inspect the receptacle for any signs of damage, such as cracks, burns, or discoloration. If you find any damage, replace the receptacle immediately. Before replacing the receptacle, turn off the breaker that supplies power to the circuit. This is a critical safety step to prevent electrical shock. Use a screwdriver to loosen the screws that secure the wires to the receptacle terminals. Carefully remove the wires from the old receptacle. Install the new receptacle, connecting the wires to the correct terminals. Ensure that the wires are making solid contact with the metal terminals. Tighten the screws to secure the wires in place. Do not over-tighten, as this can strip the screw threads or damage the receptacle. Secure the receptacle to the electrical box using the mounting screws. A fifth and less probable cause is insufficient sleeving. Non-metallic cable, often referred to as an M cable, is commonly used for residential wiring. However, it is not designed to be exposed to physical damage or moisture. Electrical metallic tubing, or EMT, is a type of metal conduit that is used to protect an M cable in areas where it may be subject to damage. Verify that the NM cable is properly sleeved with the EMT from the panel to the receptacle. The EMT should be securely attached to the panel and the electrical box using appropriate fittings. Inspect the EMT for any signs of damage such as dents, cracks, or corrosion. If the EMT is damaged, repair or replace it as needed. Ensure that the NM cable is properly supported within the EMT to prevent it from sagging or rubbing against the metal conduit. Regarding the breaker, a faulty or improperly installed breaker can also contribute to sparking at the receptacle. A loose breaker can create a high-resistance connection leading to heat generation and potentially tripping the breaker. Inspect the breaker to ensure that it is properly seated in the panel and that the connections are tight. Locate the breaker that supplies power to the dryer circuit. It should be labeled as 30 amps or 50 amps, depending on the size of the circuit. Verify that the breaker is fully engaged in the panel. It should snap firmly into place. Using a screwdriver, carefully tighten the screws that secure the wires to the breaker terminals. Ensure that the wires are making solid contact with the metal terminals. Do not over-tighten, as this can strip the screw threads or damage the breaker. Test the receptacle. Even if you have addressed all of the above potential causes, it is still important to test the receptacle to ensure that it is functioning properly. This will help you to identify any remaining problems and prevent future sparking. Purchase a non-contact voltage tester from a hardware store or electrical supply house. These testers are inexpensive and easy to use. Turn on the breaker that supplies power to the dry circuit. Hold the tip of the non-contact voltage tester near the slots of the receptacle. The tester should light up or beep if the receptacle is receiving power. If the tester does not light up or beep, there may be a problem with the breaker or the wiring to the receptacle. Consult a qualified electrician for assistance. Isolating the problem can be done by turning off the breaker and unplugging the dryer. Then test the receptacle and cord and plug separately to identify the faulty component. This will help you to narrow down the source of the sparking and make it easier to repair. Turn off the breaker that supplies power to the dryer circuit. This is a critical safety step to prevent electrical shock. Unplug the dryer from the receptacle. Inspect the receptacle for any signs of damage such as cracks, burns, or loose terminals. If you find any damage, replace the receptacle. Use a non-contact voltage tester to verify that the receptacle is no longer receiving power. If the tester still lights up or beeps, there may be a problem with the breaker or the wiring to the receptacle. Consult a qualified electrician for assistance. Inspect the cord and plug for any signs of damage such as cuts, abrasions, or kinks. If the cord is damaged, replace it immediately. Use an ohmmeter to test the continuity of the wires in the cord and plug. If there is no continuity, the cord or plug is faulty and needs to be replaced. In all cases, consulting the manufacturer. The manufacturers of the receptacle, cord and plug, and dryer may be able to provide technical assistance and troubleshooting tips. This can be particularly helpful if you are unsure about the cause of the sparking or if you are having difficulty repairing the problem. Locate the manufacturer's contact information for each component. This information is typically printed on the product packaging or on the product itself. Contact the manufacturers by phone, email, or online chat. Explain the problem that you are experiencing and provide as much detail as possible. Be prepared to answer questions about the model number, serial number, and installation date of each component. Follow the manufacturer's instructions carefully. They may be able to provide specific troubleshooting steps or recommend a qualified electrician in your area. As always, use the safety precautions described above to prevent electrical shock. Before performing any troubleshooting or repairs, disconnect the power supply to the circuit. This is the most important safety precaution to prevent electrical shock. Turn off the breaker that supplies power to the dryer circuit. Verify that the breaker is fully disengaged. Use a non-contact voltage tester to confirm that the receptacle is no longer receiving power. Wear safety glasses to protect your eyes from flying debris. Use gloves to protect your hands from electrical shock and cuts. Work in a well-lit area to avoid accidents. If you are not comfortable working with electricity, contact a qualified electrician for assistance. They have the training and experience to safely diagnose and repair electrical problems. If the problem persists or you are unsure about the cause, contact a licensed electrician for further assistance. They can perform a thorough inspection of the wiring and components and identify any hidden problems. A licensed electrician can also ensure that the repairs are done safely and correctly, preventing future problems.